All right, so here we have problem 45 from chapter 9. How much pressure is needed to compress the volume of an iron block by 0.10%? Express your answer in newtons per meter squared and compare to atmospheric pressure, which is 1.0 times 10 to the 5 newtons per meter squared. Now, if we want to compress the volume of the iron block by a hundredth of a 10%. No, I should say, let's say 0.10%, right? So we want to take this and convert it to a number we can use. So we know that when we multiply a ratio by 100, we can get the percent out of it. So we should divide the percentage by 100 to get the number out. That's for later anyway. But here we're going to be using this equation, which relates volume to pressure via the bulk modulus. And this equation can be found from, I still have the eraser on. This equation can be found from the book in chapter 9-7. You should find the equation that says the change in volume is equal to the initial volume multiplied by the change in pressure divided by the bulk modulus. So since we're looking for the pressure here, the question is how much pressure is needed, then we're going to reverse a little bit around. So we want to divide the pressure on the right side to the left side, and then also divide the volume on both sides. So we get an equation that looks like the next page. Right, so delta P now is equal to negative delta V over V naught multiplied by B. And so the bulk modulus is 90 times 10 to the 9th newtons per meter squared multiplied by 0.10 divided by 100, or multiplied by 10 to the minus 2, which gives us a pressure change of 9.0 times 10 to the 7 newtons per meter squared. And how can we compare this to atmospheric pressure? Well, we can just divide it, right? So if we divide 9.0 times 10 to the 7 newtons per meter squared by 1.0 times 10 to the 5 newtons per meter squared, then you should get about 900 atmospheres, or ATM.